honor to be here and to welcome all of you on behalf of the American Physical Society to this conference for undergraduate women in physics here at University of Chicago. You, as undergraduate women in physics, are a very special group within the APS membership. First of all, you're undergraduates, so you are at the beginning of your careers, and you are the future of APS. And so we're just so delighted to be able to have this workshop here, and I hope you find it a transformative experience. As women, you are particularly special, as we have so few women in physics. I'm sure many of you come from institutions where you haven't seen a senior woman physicist. And so we want to increase the number of women in physics. Right now, it's about 20% of our undergraduates graduating with bachelor's in physics, and also about 20% of those graduating with a PhD in physics are women. So it's been flat at 20% for a very long time. So there's a lot of opportunity to hang in there and get your degrees and to try to increase the numbers. APS is incredibly proud to support these conferences, which have been really so successful over so many years. Many young women have told me that it's really been a transformative experience attending a CUWiP conference. And in terms of encouraging them to persist in physics, to maybe then go off with a bachelor's degree and teach high school physics, or go into an exciting technical career, or a number of people have indicated that it was absolutely seminal in getting them to be excited about applying to grad school. So these conferences are really a tremendous opportunity. I hope you'll find the meeting to be eye-opening in terms of what's going on in physics, and also the wide array of careers that are open to you. In addition, I hope you find it supportive in terms of providing opportunities for networking and asking questions. And there are a number of senior women who are at the conference, and I hope you will grab them and sit down and ask them what it's like to be in physics. Enjoy the opportunity to get to know your peers who are working in physics as well. And I hope you will find that the APS can provide a welcoming and supportive professional home for you in physics throughout your education and your career. Please know that you occupy a very important place in our community of more than 55,000 physicists worldwide, in academia, national labs, and also in the private sector. So thank you, organizers. All of you, I know it's taken a village to organize this wonderful meeting. And I also want to thank some of the federal government sponsors, DOE, as well as the National Science Foundation, for helping us to run these conferences. So have a wonderful time. Take care.
Good evening. It is lovely to look at these tables. It's actually goosebump lovely. You know, it's unbelievable to see so many women who want to do physics. I think 2 years ago I was doing what Marcela will be doing soon, talking to you as an after-dinner speaker, and I went to a dinner similar to that, but actually there were fewer men. We only had 2, my husband being the other one, and he walked in and he said, "Oh, maybe I shouldn't be here." And I said, "That's exactly what happened to me in graduate school at MIT. I walked into this room and I said, oh, maybe I shouldn't be here." I was the only other woman, so we were 2 women and 60 guys. So if you are in that situation, I'm hoping, you know, many years have passed. I have lots more wrinkles than most of you, so hopefully you're not the only woman in the 60 male school class. But if you are, just hang in there, because, you know, we are brilliant, we can do it, and we can even become dean, which is not a brilliant choice. But it is something that I had to do recently to, keep doing a little bit of history, right? So I just wanted to thank you for coming. Thank you for being excited about what I think is the loveliest field. I think understanding nature at its essentials is so beautiful. And the one thing I would say, aside from don't give up and it's going to be great whatever you decide to do, research or otherwise, is that living close to the edge of knowledge is really wonderful. So get involved in research as early as you can, even if you don't really know what is going on in that lab for a while, because you will very quickly realize that we're all trying to move that boundary, and that is, everybody can help, including undergraduates. So that's what I would do. Just to remind you, I'm the Dean of Physical Sciences at Chicago. I just wanted to let you know what that means, because other schools are differently organized. The college is where the undergraduates are, so one of our tasks is to try to connect to the college students so that they are involved in the research, because the research is under these divisions. In our case, it's 7 departments, so it has physics, mathematics, geophysical sciences, astrophysics, which is where I ended up, and I think K2 followed, started in physics and ended in the astro side. And we have mathematics, computer science, statistics, and chemistry, and I think I covered all the 7. If I'm missing anybody, please tell me. Anyway, so that's where we do the research, that's where the faculty are, but the college is how it gets to organize the different majors, and there's a little bit, we try to be liberal arts, make, you learn all kinds of things aside from physics, including speaking. And obviously, I didn't come here as an undergraduate, otherwise I would be speaking better at this point. I went to only physics in Brazil, so any Latin Americans in the room? Oh, right. We have, I know there was at least another one, and you'll hear from her later today. Anyway, I wanted to make this short because everybody's, tired. It was a long day. But thank you for coming, and I hope you're enjoying. I was also at Argonne. I saw your bus go by while I was visiting the accelerator part of the X-ray facilities. So welcome to the University of Chicago. I hope you enjoy your time here. Some of you will stay longer periods, but please go transform our view of nature by doing more. Thank you so much. He and I have been spending the whole day together.
Partly at the other APS, that is the Advanced Photon Source at Argonne. So my name is Matt Terrell. I'm the Dean of the Pritzker School of Molecular Engineering, which relies heavily on physics. It is the first ever engineering program at the University of Chicago, started 2.5 years ago. And molecular engineering is really what a lot of people would describe as nanotechnology. We wanted to use a more distinctive term, but what we mean is engineering systems from the molecular level up. And that obviously relies on basic science in many ways. You could think of us as translational or applied biology, chemistry, and physics. To echo what Dr. Kirby said, of course, I hope many of you go to graduate school or to employment directly using your physics degree, but engineering as a career path is also something you should think about in our own program. We have, our philosophy really is not to build a traditional school of engineering, but rather build themes or focus areas where with a group of people of about a dozen, we can get to a leading position. So we have 3 themes: material systems for sustainability and health, immunological engineering, and quantum information engineering. And of course that latter is squarely in the domain of applied physics. Among our now almost 40 faculty, about a third of the faculty have their degrees in physics. About a quarter of our students have their undergraduate degrees in physics. So we rely heavily and really want to make ourselves attractive to people like you. So thanks for coming here to look us over and to learn about us, but more importantly, to learn about the field and its opportunities broadly, because they are enormous. And I hope you have a great time. I hope you've had a great time and that you'll have a great time tomorrow. So thank you for being here.
I'm a medical doctor, not a physicist. About 3 years ago, I joined the Provost's office, which is part of the central administration. And one of the reasons I did that was because unless people step into positions of leadership, we're not positioned to help people change systems and make a pathway for people who come along. And so one of the most important issues for me, in both my research as well as in the work that I do in the Provost's office, is thinking about issues of women in STEM. And so more recently, I've been involved even at the high school level of thinking about women in the sciences, and I've had the opportunity to work a lot with the physical sciences division and with your next speaker, Young-Ki Kim, around the issue of women in STEM. And it really relies on the pathway, not only the people who come along. And so it's really, really important, not only that we have people themselves who want to be faculty and researchers, but also we need a STEM literate population, people who understand the issues and understand science, so that when you read something in the newspaper, you don't dismiss science as something that's critically important to everything that we do, to our policies, to the way we think. And increasingly, we're understanding that STEM and science and being able to think in a scientific way is really how we implement, how we think through many, many problems. It brings a really wonderful spirit of experimentation and problem solving and comfort with failure. So I really encourage you, I'd love to see many of you go all the way, and certainly these types of conferences are part of it, but also to engage deeply. Don't be afraid to fail. Don't be afraid when you're the only person in a room to stick your hand up, ask questions, admit that you don't know something, and really be persistent. So in my life, I've made lots of mistakes, and I picked myself up and moved forward. I've spent many years in basic science research labs, and then I was like, no, that's not right for me. I was even a general surgeon for a year. No, that's not right for me. So you also get lots of do-overs. And so, but it's that process of learning and that openness to continuing that learning process, even if you go into a room and you don't see a lot of other people who look like you. And that's important of spaces like this, and this is why the University of Chicago has such a profound commitment. It's a very long-standing commitment to physics, but we also have a long-standing commitment to education and to inviting people like you all here, really with the hopes that you also get energized and excited about the work that we do here and the possibilities for your future. So welcome from the administration, and thank you so much for coming through the Chicago weather and being with us today. So thank you.
Okay, hi, I'm Young-Ki Kim. I'm chair of the physics department here at the University of Chicago. I'm a bit short, so I'm lower. I don't want to do too much. I think I can do this. Or I can speak loudly. So on behalf of all the members of the physics department, I would like to welcome all of you to the University of Chicago for the CUWiP. Angela said that, seeing many of you feel goosebumps, and I feel the same. It more so, I remember my first engagement in CUWiP in 2010. I gave a keynote speech for several sites. At that time, I remember all the several sites all together. It's about 500-ish there people, as all women undergraduate students. In 2014, in fact, I chaired the CUWiP at the University of Chicago. At that time, we had all sites combined, about 1,000. Now, to year 2020, if you cite all combined, it's 2,000. So it's really, it's amazing. It's just fantastic. So I don't want to make a long speech because we're getting tired and etc. But also I'll be hanging around, so we'll have more chance to talk. But I just want to first thank American Physics Society for their support. As this whole CUWiP is getting bigger and bigger, we need a more professional help, and APS has been really providing enormous support. So on behalf of all of us, let's thank Kate. And also, I told you I 2014 CUWiP. And from that experience, I know how much work is involved. So I would like to, first of all, have all the CUWiP local organizing committee. Could you stand up if you're organizing committee members? So big round of applause. I know I'm getting emails constantly, so I know how much work they are doing. So it's incredible. And then we have our very strong, very dedicated support staff members. Are they here? Of course, they do a lot of work behind the scenes, so let's give a big applause. And also we have the volunteers. Could you stand up for volunteers? So you will see that anytime, anywhere, if you see the blue shirts with this pattern, you can ask, Professor Nagel or other members what that means. They'll tell you what that has a very deep meaning under that. So they're also fun to find out. So with that, again, I'd like to welcome and I'd like to thank everyone.
First, let me welcome everyone to Chicago.
You have
Raise
to
your
lift
microphone.
it, yeah.
Can you hear me? Let me welcome everyone to Chicago. My name is Saf Sathi. I'm one of the organizers, along with Linda, and all of our blue-shirted organizers in the audience. And I have the pleasure of introducing Marcela Carena, who is our first plenary speaker. We're very fortunate to have her speak. Marcela is currently the head of the Theoretical Physics Division at Fermi National Accelerator Laboratory here in Batavia. Some of you went on a tour this morning and got to see Fermilab. In addition to her role at Fermilab, Marcela is also a professor of physics here at the University of Chicago in the Enrico Fermi Institute and also in the Copley Institute for Cosmological Physics. She has a long list of honors. She was a Humboldt Fellow, she's an APS Fellow, and today we're very fortunate to have her tell us about her life and exploring our universe. Let's welcome Marcela.
Okay? Yes, good. Right. Good. We are ready? Yes, okay. So, well, I'm super happy to be here tonight. We already heard amazing good speeches about how great it is to be here and be part of the Conference for Undergraduate Women in Physics. For me, it's my third time, so I'm very happy. I know everybody's tired, but I'm not very good at doing things short, so I will do my best. She's going to be on my back. Okay, so I will start. This is a kind of funny talk, so I don't know if I'm pitching it right, but I will try to tell you a bit about my path into physics with the hope that that will be helpful for you. And then I will tell you a bit about the things that I'm excited about thinking in physics, okay? And then I will have some very small concluding remarks. So, about me, okay, so I'm a theoretical physicist, so I don't touch any instruments, not to break them. So I do the research in particle physics. As Sab said, I'm the head of the Fermilab Theoretical Physics Department, not division. Josh will be very annoyed with you if you take his job. I teach here at the University of Chicago, which is a pleasure. And I do a lot of work on international relations with the idea of bringing, and I will say a few words about that, bringing scientists from around the world closer to Chicago area and to Fermilab. I'm the mom of two amazing young men that I will introduce them to you, and actually they bring me much closer to you because one is just started as an undergraduate and claims he wants to do neuroscience, and the other one is just doing his PhD in physics from all the things. So I also have my husband, Carlos, who is sitting there, and he's also a physicist at UChicago, and I would say he is my collaborator in life. So
it's really important. Things I like doing, I love cooking and eating. Also, some wine is good. And sharing time with my good friends. I really get excited about some things, and while I was doing this, I said I love bungee jumping, scuba diving, horseback riding, dancing, and adventure trips. And bungee jumping, the first time ever I did bungee jumping, I did it almost together with Angela, who is our Dean of Physical Science. So, she also likes bungee jumping. And of course, I keep very close ties with my extended family and friends in Argentina, where I go super often with my family. So that's in a nutshell me. That's me pregnant for my second son. How I came to be a physicist. Okay, well, it was not a straightforward path at all, and I will try to tell you that briefly. So first of all, my mom wanted me to be a very well-educated young lady, and she was very good at it. So I spent quite an amount of time in my youth doing things that were not very close to physics. And, but of course there were other things in my life that really changed the perspective I had in looking at things, and there were two things I want to mention. One is that I had an amazing role model that was my math teacher in high school. She was super passionate, and she made me feel that was amazing to try to solve challenging problems. Okay, so, and she also told me while I was there in high school that it was an amazing place in the south of Argentina, close to the Andes, to really study physics. So that was the first time I heard about that. The other part was my father. And this is half a joke, but not really. So totally unintentionally, he prepared me the best he could to be a physicist. He just ran a little ranch in Argentina. And so during 9 months per year, I was doing what my mother dreamed that I should be doing. And during the other 3 months per year, I was in the ranch. And so in the ranch, everybody, that was a men's world, of course, so everybody would bring their son to the market, to the cow market, to be with them and, you know, kind of bind together and so on. Unfortunately, my father only had me, and so he decided to bring me there. And so that was my first experience to be different, okay, because I was the only young lady among all the guys, and I had to learn how to survive and make friends in that environment. So that was a good thing. I think, however, that my desire of thinking about physics came really even early on, when I was like 6 years old or so. Again, going to this area in the a bit north of the South American Big Apple, that is Buenos Aires. And so we would go there to the countryside, and in the deep darkness of the night, because there you are, you know, with the stars, is amazing. My friends and I, we would just sit down and look at the sky and be absolutely amazed by the countless stars. And although we had no idea what was the physics connected to those phenomena that we were observing, I think that was really breathtaking. So in reality, when we think about physics, what we do is we think about the science that matters to all of us, and we want to know how we all got here, how it all works, from the vastness of the space to the smallest parts that we can see. Not with our eyes, of course. So let me just tell you a bit about my career path into physics. I started as an undergraduate in Argentina. In reality, I was really, as I said, I was really good at math in high school. My high school was a liberal arts one, so not really very challenging, really. And I didn't know what to do. So because I was doing math, I decided to go into engineering. And about 10% of women were in my class. And so in my second semester, and was in a study group with another 6 guys. And we had, our job was to design a bridge, okay? And so I did my best, I swear, it was so obvious. All of them were so excited about thinking how to design the bridge. And for me, I really didn't like it at all. And in fact, I'm very happy, I think, that my design bridge was never built, because otherwise, of course, we have been in that situation at some point. It would have been a real threat to a lot of people. So because I was not convinced, as I said, with engineering, I decided to go and study philosophy. And I thought, okay, philosophy asks all the exciting questions. In reality, asks the same questions as physics. Okay, it's just the answer comes differently. And I have to say, and I apologize if anyone here is thinking about philosophy, but I found it too fluffy. So, however, because I'm a very stubborn person, I kept philosophy and I kept engineering, and after 3 years, I was ready to give the admission exam for physics. That was in this place, close to the Andes, that my teacher spoke to me back in high school. And again, only 10% of the admitted people were women, so it was okay. It was a bit worse than now, I guess. But I went there and I really started thinking about all the things I wanted to learn in physics, and it was a real awesome experience. It was a place in the mountains where you could learn ski and physics at the same time. So then after that, I had the unique opportunity, actually Carlos and I, we had the unique opportunity to go to graduate school to Germany. And as an undergrad, I was really very fascinated by learning how to use math to make sense of our world. And so that's why, for me, it was really very natural to think about theoretical particle physics. And so I started thinking about the most basic questions. Some of them I have been thinking for the last 30 plus years, but okay. So, for example, why there is more matter than antimatter. Besides the symmetries that we know in the standard model of particle physics, are there other symmetries in nature? Are there other extra dimensions of space in nature? And the big question that got an answer recently is how do elementary particles get mass? So, through the Higgs mechanism, I will go back to that, but this was not there until 7 years ago. Time flies, okay. Moving forward, so I graduated from Hamburg. I have to say that in Hamburg, when I arrived there were 2 things that were problematic. The first one, my English was much worse than now, if you can believe it, and my German was non-existent. And so, in a full year and 9 months, we had to finish our PhD and pass a very demanding German examination. So that was an extra bonus of doing a PhD in Germany. So it was good. So moving forward, I think I have the best years of my life. I shouldn't say that because they are past, but okay. In my postdoctoral experience. I mean, I had a postdoc in the US, one in Germany and one in Switzerland. It was awe-inspiring science. It was the first time I really felt I had complete intellectual independence. I had this opportunity to work with brilliant colleagues and mentors, and it was a very international community that by then, I would say I love the idea that physics is so international as a field of study. Of course, there are other things that were more complex, like it's a very competitive environment. You don't have any security for the postdoctoral years because after 3 years or so, you are jobless and you have to start again. Hopefully it goes well, but you never know. The salary is certainly much less than in the private sector, and that has become much worse now. I think. At least I'm trying to retain my postdocs and I learn about that.
You mean the private sector? Okay.
The private sector went up, yeah, we stagnate. And then of course, it's very challenging for relationships and for family. And by the end of my postdoc time, I decided that it was never the right time to start a family, but by the end of my postdoc years, I decided, okay, let's jump into it. And there I had first Sebastian, my older son, and Julian, the youngest. And then we moved into tenure track and tenure experience. I have to say that I came directly to Fermilab as a tenure track or associate scientist. I was tenure super fast. I have many promotions regularly. I have a very good experience in my tenure life. Okay. So I became a professor at UChicago sometime in between. And now I'm having the pleasure of trying to make the best out of the Fermilab Theoretical Physics Department. And if some of you were there, I hope you enjoy visiting at least the high-rise. I live in the third floor. In the meantime, things evolve on the other side. So this is now my son Sebastian, who is, as I said, he didn't learn the lesson and is trying to become a PhD in physics, in theoretical computational cosmology. He did not want to come to Chicago, I have to say, because the parents are here. And this is my youngest, Julian. He claims he will go and do neuroscience, so we will see. He also didn't want to come to Chicago. But it's not because of Chicago, it's because of the parents being here, I think. Well, although they don't tell me that. Anyway, so let me just shift gears a little bit now and tell you a bit what is the science I'm excited about. So the questions I have the privilege to spend time on are really the questions that are fundamental for particle physics. What makes particles massive and slows them down from moving at the speed of light? This is, of course, the same as asking why the world that we know is possible, and is totally connected with the existence of the Higgs boson. The second one that is very important is what really holds the universe together and gives us these distorted images of distant galaxies. And of course, we know by now that we call that dark matter. We don't have a clue what it is. So this is really the next challenge. And one of the other challenges that I have dedicated basically most of my career as well is trying to understand the origin of the imbalance between matter and antimatter, so why we are here, okay? And of course, there are two options that are my preferred one is that it is related to the Higgs field. There is another option that is related to secrets encoded in the tiny but mighty neutrinos, and I will hopefully tell you one slide about that, although Linda is looking at me with serious eyes. Okay, so I have had the privilege of working in the two largest high-energy physics laboratories in the world, the CERN laboratory in Geneva, Switzerland, and the Fermi National Laboratory here in the outskirts of Chicago. And big science questions, as the ones that we are trying to ask in high-energy physics, require technology innovation. And it's in those laboratories that these advanced accelerators and ultra-sensitive detectors are mostly built and operated. Okay? So these are the two detectors where the Higgs was discovered in 2012. They are basically as big as cathedrals, and they are amazing. You know, if you look at these, they are literally kilometers of cables going around. And when I look at them, I feel so amazed by my experimental colleagues because it works. Okay? So let me just show you a movie. It's very short. A movie and a story that comes with it is that I told you that, in fact, in 2012, the Higgs boson, or the God particles, people say, was discovered. This idea of the Higgs field and the Higgs boson was thought of half a century before the discovery. And so, again, where is it? No, please don't do that. Okay, here. So this is the accelerator complex in Geneva, Switzerland, so with the Atlas and CERN, Atlas and CMS detectors, and here is the proton going at the speed of light, crossing the border between France and Switzerland, no problem. And you see there the quarks inside, the blue ones, they're not depicted. So they go really at almost the speed of light. The beam collides like 40 million times per second, so that's amazing. And then at some point when they collide, they basically are at energies that are very close to a billionth of a second after the Big Bang. And so they collide and they form new particles that were present very close to the origin of time. And then they decay in other particles, and finally in particles that with these detectors we can trace. Okay, so this is a Higgs event where the Higgs boson went into two Z bosons, and one Z boson went into two electrons and the other one into two muons. Okay, and so we reconstruct the tracks and we are able to say, hey, this is a Higgs. Okay, so the discovery of a Higgs boson, in reality, what it proves is the existence of an invisible Higgs field. That is a field of energy that permeates the whole space and has as a property to give mass to the fundamental particles. And given the time, I will not go into a lot into that, but please feel free to ask me questions. The only thing I want to say is this is, sorry. So this is me, this is Mr. Higgs. This is my good friend Fabiola Gianotti, who is the Director General of CERN, so she is really the most powerful scientist, physicist at this moment. And this was at the Nobel Prize ceremony. And the important thing I want to say is that here Mr. Higgs was explaining to us that when he thought about his paper in 1964, the paper was rejected. And it was rejected because it did not have anything to do with real life. Okay, so this, I think, is something to think about, that first of all, that reviewers may be wrong and may have a lot of prejudice, okay, so don't be that. And that obviously these labors are so challenging mathematically, and it took 50 years to have the technology to prove the theory, okay? So, moving fast forward, so the power of the dark side, this comes from when my kids were small, I guess, but so the point is that we know today that 85% of all the matter in the universe is what we call dark matter. What we don't know is anything about it, okay? So that's a big challenge. I mean, at the same level of the Higgs many years ago. So dark matter, why we know? There are many reasons, but they all have to do with gravitational interactions. Okay, if you look at these rotation curves, in fact, the idea is that if you have some star farther away or a galaxy farther away of the center of the cluster of galaxies, the velocity should drop with 1 gram, so with distance, and so it should be like this. Instead, it goes like this. And what this tells us is that this is the luminous matter we see, but there must be more matter around here that explains this behavior of velocity. The same thing is what we observe here is that distorted images from distant galaxies, and what happens here is that there is matter that we don't see that is bending the light through its gravitational effects. Okay, so, and when you put everything together, it actually matches that the amount of dark matter that you need to explain these distorted images goes well with the amount of dark matter that you need to explain this velocity profile. Okay, so I will be brief here. So dark matter exists, and we are just awaiting discovery. The only issue is, since we don't have a clue what it is, it's not so easy to discover it. And this is where theorists are useful. Sometimes we are useful. Not always. So of course, the experimentalists are using accelerators, telescopes, and very specialized detectors to search for dark matter. There are some dark matter from space would collide with a single nucleus very deep underground in the detector and would be observed like a recoil. Also, at the Large Hadron Collider in Geneva, Switzerland, we are hoping that we will be able to create dark matter and then see the tracks of this dark matter. The tracks of the dark matter will be actually seen through the missing energy, and especially missing energy in the plane transfer to the beam of particles. Or we can see it also in some particles that we have not seen yet, and then it will decay into dark matter. Theories come in putting these both informations together, trying to understand which models could work and which models could not, by looking at these experiments and mapping one into each other. And this is one of the things I have been doing actually since I basically, very much since I started working here in the Chicago area. So we know that the dark matter interacts weakly through gravity, but we don't really know, for example, if it talks at all to the Higgs. That's a question that is very interesting. You know, now we know that the Higgs is there. Does it talk to the dark matter? And if it does, how? It could talk directly or it could talk indirectly. Dark matter could just talk to all the particles we know through some portal. One simple example is, you know, we have a dark sector with dark matter, with some dark scalars, and these dark scalars talk to the Higgs, and the Higgs talk to us. Very simple example, okay? What I want to say here, without going into further ado, is that the amount of theoretical ideas flourishing to explain dark matter is countless, no, not countless, but a lot, and is a priority for particle physics and cosmology. So again, I will kind of jump into this, but we don't have a clue on the mass of dark matter. It could be 10 to the minus 22 electron volts or 30 times the solar mass, anywhere there. If it is really small and this has these QCD axions, it's more a wave-like thing than a particle. If it is somewhere here, these are the WIMPs that I'm sure you heard about, weakly interacting massive particles, kind of the vanilla dark matter. But they are, as you see, these are all theories that would explain the relic dark matter density that we see in the universe and would explain these rotational curves and these distorted images of distant galaxies. Okay. If we want to make some assumptions, theories love to make assumptions, to make our life a bit easier about the early cosmology, then we can assume that at some point they were out of equilibrium and exchanging with the standard model particles, and then as the universe cooled down, there was like what we call a freeze out, and so they become out of equilibrium, and some relic amount is left, and this is what you have today. Okay? But in any case, the phenomenology of this dark matter is very rich. It's natural to think that if there is dark matter, why should be only perfect? Why should be only the only dark? Dark means that it doesn't interact, doesn't talk to the standard model particles, correct? Why should be the only dark part in the universe? So naturally, and I won't go into this, naturally we think we have the standard model, we have a dark sector where there could be a lot of other particles, where dark matter is, and there are some connections, some mediators, some portal that is connecting one thing to the other. And this is the idea that we do all the modeling. So, neutrinos, I won't say much, but I want to say only that neutrinos are the most abundant particles on Earth. They are very elusive, very distant, and in principle they are so interesting because it may be one of the possibilities is that they hold the secret to explaining why there is more matter than antimatter. And so at Fermilab, oops, sorry. At Fermilab we are building a new experiment that will go from Fermilab 800 miles down Earth. You don't need a timer for the neutrinos, they go on their own. They don't ask for permission. And they will hit detectors of 70,000 tons of liquid argon 1 mile underground. And we hope to learn something out of that, hopefully. As I said, I have to do the disclaimer. I hope that really the way that we explain the matter-antimatter asymmetry has to do with what we call electroinvarogenesis, that mainly has the Higgs as the main claim. Okay, so wrapping up, other things I'd like to do is to bring science to the public. I have started that about 10 years ago, so I'm not so old in that business. We started with a nice film here, in which Carlos and I, among other things, appear dancing tango. We have to go and practice again because we couldn't do the film now. Then, of course, came Angels and Demons, and the fact that antimatter could destroy the Vatican and all these things. So I went around and I gave a few public lectures showing that the idea is okay in principle, but in order to build the amount of antimatter that you need to destroy the Vatican, that is a quarter gram, you would have needed at Fermilab 190 million years. So not so practical. And you will have a space of a football field that you will have to basically kind of go through the Swiss border in order to go to Rome and so on. So probably they will be suspicious, the Swiss guards. So it's not very, so that was fun, a lot of fun. Then this is again matter-antimatter in this World Science Festival, understanding what happened after the Big Bang with LHC. So I like to do that. I also like, the pictures are not gorgeous with the light, but I also like to work a lot with Latin America. As Angela was saying, I originally come from there, and I'm trying to, I feel it's good for me to give a little bit back, and so I'm leading the effort of the Fermilab International team in building connections with Latin America and Cuba. So basically what I do is I try to talk to the science and technology ministers and the people that have some power. Once Kate helped me very much. In fact, to go here, Kate, that's what, thanks to you, I am there. And so we talk to them, and what we do with that, we validate what our colleagues are doing in the different countries. Of course, in Europe we can do that too, and Europe does that for us, but for places like Latin America it's crucial because our colleagues there, they are not really valued as they should, and especially not by the ministerial powers. What else? I forgot. Oh, okay, so these are almost there. I made this list. I have to say that the first time I made it was 3 years ago, and my son Sebastian, who was an undergraduate, read it and gave me the okay. I'm corrected too. It's true. What are the challenges? It's very competitive to do a career in physics, requires a lot of personal flexibility. It's a male-dominated field, so which means really that requires extra efforts to have the same opportunities. It's like that. I think it's still like that. Hopefully this will be changed, but at the moment it's like that. And I would say, well, the salary is an issue, of course, but we do it for love. It's not just a job, but it's a lifestyle. And I think this is doing not only physics, doing research and basic research is a lifestyle. And so many times one needs to accommodate a lot of personal commitments, to travel, and of course there is no guarantee of success because you are trying to test things that you don't know the answer for. So you are exploring, right? You are doing an exploration. So Mr. Higgs was lucky that he was not dead before they discovered the Higgs group, but he was 85 years old. So, on the other hand, rewards, incredibly rewarding career path, I think it is true. No limitation to the projects or to the way you can let your mind direct the things that you are interested in working, especially, maybe your advisor tells you do ABC, but as soon as you still can push back, I recommend it. And also, I would say that as soon as you have, you become a postdoctoral fellow, you have independence to ask the questions that are most exciting to you. I think there are parallel mentors opportunities with the world's most brilliant minds. There is academic independence. There's lots of opportunities for international travel and collaborations, which I value. And excellent possibilities of switching outside academia at any point in case you decide that that was too much for you. Okay? Because you are prepared to be a problem solver. And so that's why it's so easy to get jobs outside academia, because you are very well trained to solve problems, not only the problems that you are thinking today. Okay. So to finalize, I want to say that there is a community of women in physics out there. I will show you these 4 slides that are my friends and my closer colleagues, but there are many more. This is Fabiola, the Director General of CERN. Yankee, you just heard, is our department head. Elena Prile is the spokesperson of the most impressive dark matter detection experiment in Gran Sasso in Italy, Xenon. Lisa Rahman is a Harvard professor who put on the table an amazing idea of these warp experimentations and write amazing books about dark matter and dinosaurs. Noshin Shah is an alumni from Chicago. Ikun Wang is my student now. I thought she was going to be here, but she's not. These are postdocs and faculty at Fermilab, vice chancellors, very successful women working in an experiment. This is Ornella, my colleague at Fermilab, working in the forefront experiment for neutrinos. This is Idoni working on dark matter experiment in Sao Paulo. This is Gabriela Gonzalez, also from Argentina, and if you want, you could watch her telling you how LIGO discovered gravitational waves. She's also in the same big experiment for dark matter. Nina is a student from UChicago at the moment who just won a DOE fellowship and is working with me at Fermilab. Angela, you just, you know, she's the dean of UChicago for physical science. So she's amazing, and she's also the PI for this amazing experiment to look with these super pressure balloons for cosmic rays, correct, and study neutrinos. These are professors at the University of California, Santa Cruz. She's a professor in Zurich. More people here, professor at Caltech, professor at Northwestern, also in LIGO, also professor in 2 different other universities. All these people are my Spanish friends, from Spain actually, and they were having a lot of fun in Visibles 19. So all this group of women, and I just took you know, a few handfuls of them that are really the people that I'm more connected to, are there, opening the path for you, and are really going to support you and to give you advice and to, you know, try to make the best of your career whenever you try. So please take advantage of that. We are all here, you know, we went the path before and we hope that we can pave it a little bit, so each generation does the same for the generation to come. Thank you.
There's no microphone. Let's see. So we have time for some questions from myself. Oh, the microphone.
Thank you so much for what you just said. It was wonderful. So as you reflect on your career, what do you think made you this successful physicist who stands before us and tells us really good advice?
Well, I said something that is that was there quite clear, is that you really have to work very hard, because you have to be you are in a male-dominated world, and many times these things come back to you. I would say that I have like a turning point in my career. That was when I became pregnant for my first child. And up to that time, I was really trying to accommodate to the society around me. I was trying to look like a guy. Not look like a guy, but act like a guy. And then I became very pregnant, okay, and then I realized that people only saw my belly, okay, and I said, well, you know, if from now on I will do what I think is my way of doing things. And you pay some price for that, but I think it's the best you can do. So what I would recommend is that you work hard, that you are very serious, very respectful of your colleagues of any gender, but that you are true to yourself and you do what, because if you're not true to yourself, you really cannot get your mind, get yourself in the state of mind that you need to do science and to do research. So for me that was a breakthrough when I decided that, okay, from now on, I am the way I think is good for me.
More questions?
So, talked a bit about your background, starting with engineering and then philosophy, finally moving on to physics. What got you into particle physics specifically? What sort of connections, or at what point in your, physics academic path did that happen?
Well, it was, I think, were two things. One, the fact that I was doing my undergraduate in Argentina, and all my professors were, or the best professors I had were all doing particle physics, so that was kind of a role model, correct? Also because, today it's much easier to, communicate with the outside world, but at that time things were a bit harder, so the internet was not there yet. And so it was easier to do theoretical physics than experimental physics. I don't know if I would have been, pushed into experimental physics, how would I have felt. But the particle physics part, so this is for theory versus experiment. The particle physics part, I think, has to do with the questions that particle physics asks, that are for me, really exciting, and they're very close to the ones, they have to do with how come that we are here and we exist, which means why there is matter rather than nothing. Understanding how the universe works was for me the hook into particle physics.
So obviously in undergraduate and graduate school, you mentioned having to work really hard, and a lot of times we just have to put our head down and chug through it all. Was there a moment when you were able to kind of look up beyond yourself and start supporting either other women or minorities in physics rather than just kind of focus on yourself and your own work?
Look at other women as inspiration, is what you say? Or I'm sure I got the question right, I'm sorry.
When were you able to kind of turn around to start supporting others? Like,
Ah.
people were able to look up to you?
It takes some time, I guess. I think I learned my lesson the first time when I came to Fermi Lab as an associate scientist. There was a postdoctoral woman from a colleague of mine, so a student from a colleague who came to Fermi Lab, and I really think I failed her completely, honestly, because I was overwhelmed with myself, correct? I moved to Chicago. Carlos was staying at CERN for 3 years, and I moved with Sebastian 1 year old. I was the only woman in the department. I was overwhelmed with myself. And so I failed Heather, and we have talked about that, completely, because I just couldn't handle all what I had. But then, slowly you start feeling a bit more better in your skin, and then you start doing little steps. So I think that after that, it was really like my first experience being what you say, a young professor, yeah? Which didn't go so well. I mean, not didn't go so well. I worked with her and so on, but I was not really supporting her. I start being conscious, and of course this, you know, it grows. And I think you naturally tend to do that. And sometimes I think I see that at Fermilab, for example, among the postdocs or the students. You know, now of course they were sitting there, and we were 5 women sitting trying to do a project, and I said, wow. We are 5 women trying to do a project, which is good. But yeah, it evolves slowly, and of course, you know, when I was younger, I was good friends with Fabiola. She was a postdoc, I was a postdoc. We would, you know, support each other, but I couldn't do much more for her than just being a good friend / co-postdoc.
So you talked about teachers who encouraged you, who like saw that you were good at math and encouraged you to kind of pursue physics as part of how you ended up in it. And I'm just wondering, obviously you walk into a room and no one else looks like you. There's already like a challenge of feeling like maybe you're not supposed to be there, but did you also, I don't know, have encounters with the school that you were in or the teachers that you had, feeling like you weren't being supported by them the same way you're being, like, your male classmates might have been supported?
Well, I went to an all-female high school, so I didn't have that experience. So I went from a religious all-female high school, very conservative and very liberal arts, to the engineering university, so that was a shock to my system, I have to say. We had like an admission preparation course where we were, I think, about, what, 280 people and 10 women, so something like that. That was really crazy. That was my engineering part. So that was difficult. And then when I went to the south of Argentina, again, there was like a boarding university. We were like secluded there. Okay, they call it the MIT of Argentina. I don't know enough about MIT, maybe it's good like that. But I also was very hard for me to accommodate. I mean, it was hard for me to accommodate also when I started physics. And there I don't think there was, you know, were 3 women and 33 students all in one big dorm. And it was rough. But, you know, I think that, and I wouldn't say that there was much encouragement there, I would say. But, so that's when you have to, you know, go back to yourself and say, well, you know, and it's not always easy, correct? You feel that it's not only because it has nothing to do with your, of course, with your capabilities of doing the science, but, you know, how do you feel with the surroundings? And so, yeah, you have to toughen up, I guess, a bit, then it goes well. I mean, mostly my main student colleagues, they were all really nice and friendly, but it still was an environment where me and another 2 were the minority.
You mentioned you finished your doctorate in Germany, and did it even though at that point you said your German was non-existent? I'm sure that must have been very challenging. What led you to decide to do that?
No, the thesis was written in English. Otherwise, it would have not been possible. Believe me. But we were required to have a big exam, level exam, in order to stay students of university. And so we have like some very minimal amount of time that we have to make to pass the exam, comprehension exam in German. So that was pushed me to learn German. I have to say I'm super thankful. Of course, at that time I was not, but I'm super thankful because I would have not learned, not that my German is so perfect, but I would have learned any German if I would have been under that pressure. And then I did another postdoc in Munich, and you know, and And this is part of, and now of course I go to Germany very often and I have a lot of colleagues there. And it's something that I got for free, I would say. I got a few languages for free. Italian, German, improving my French, thanks to physics.
Portuguese.
So that was good. That was good.
You didn't mention
Portuguese, yes, but Portuguese I only counted half a language. Half a language.
It's okay.
But I will improve. Now that I'm going to go to Rio, I promise. I promise. Sergio makes me speak Portuguese. You switch to English.
I know, it's faster.
Yeah. No, I'm working on my Portuguese. Yes.
There's one more.
How has being a professor at the university contributed at all to your position or career at Formula, or vice versa?
Well, I think at Fermilab I started earlier for different reasons. So what gives me the position at university is the contact with students, and also I think teaching keeps you upbeat and fresh. So that's good. Again, it's like learning German at the moment, the day before the class, put that away. But I think, and it's a different atmosphere with a lot of young people. In fact, I try to recreate that a bit of the theoretical physics department. We're trying to get students and postdocs and visitors that are at the student level. We don't have a lot of students, we have a few only. So it's a very different climate, and depending, I would say depending on the moment of my life, I have valued one more than the other. Okay, but both are very interesting. So I'm lucky that I have both opportunities.
You mentioned that physics field requires a lot of hard working, and I would assume a lot of education. How would you describe your process of finding resources, like opportunities, scholarships to fund for your education?
That's a difficult question because it depends a lot on where you are. Okay. So when I went to Germany to do my PhD, I was granted a fellowship to do that. Otherwise, I probably couldn't have gone. And these days, there are many opportunities. There should be more, I think. I think everybody, at different levels, people are trying to generate opportunities for students in physics, and especially for women, for female or diverse students in physics, or minorities in physics. And it's working, but we have to do much more. And I think there are different ways, like, as I said, Nina, she got a fellowship from DOE, to come for a year to work at Fermilab and have a different experience. There is some connection between, we built some new scholarships between UChicago and Fermilab, and UChicago and Oregon to have students having both experience of the lab and university. So there are opportunities. I think you have to search for them. And really depends where you're standing, what is your place. But there are opportunities. But they are not just hanging from the trees.
Final question.
Was there any point during your career in which you feel your colleagues started to see you less as a female and more for your quality of work? Like, has there been a point in your career where you felt that?
Well, after the pregnancy issue, when I saw that everybody was seeing me as the mom of the baby who was coming, in spite of the fact that I worked so hard that year, because I didn't want anyone to think that because I was pregnant, I was not working as much as any other postdoc. So I think that at this moment, I feel like, you know, I don't feel that anyone would come to me and say, consider less of my work because of being female. They may consider less of my work because they don't like it, but this is a different thing. but you are trying to tell me, ask me when I did this transition, correct? And this transition is very gradual because it depends on the people that you are looking up to or looking equally or down, maybe, I don't know. So I think it gradually happened, okay? Of course, you know, at some point I became a distinguished scientist, and so that's like, you know, distinguished professor for Fermilab, and there are very few people that have that, and so that, of course, made me feel quite confident. But I think that it really, it comes from you, I think, a lot, correct? I mean, obviously, sometimes you are not blind and you perceive that people are not taking so much seriously, or there are these little things, but people are working very hard. People means our community, working very hard to put that at rest. Yes, I have a situation where you're in a meeting and I say, you know, this tablecloth is white, and then he says this tablecloth is white, and person X says, as he said, the tablecloth is white, and you said, I said that also, but what happened in the middle, correct? So you are not heard. That happens. It doesn't happen to me now, but I'm Fermilab because I'm the boss, so of course. but it happens, and so you have to, you know, take it calmly and don't lose your, you know, your posture, and try to make it. You have to try to bring it forward and give yourself also the place. And so it's both ways, I think. And we all have to learn that. And I think probably men also have to learn that for women, you know, if we're in a place where the majority, like now, will be women instead of men, would be the other way around, I think. So you need just to put it in your mind that, yeah, you have to make the other feel that your science is first.
I couldn't imagine a better start to the conference. Let's all thank Marcela for